6 moles of hydrogen fluoride is added to 4.5 moles of silicon dioxide, which is the limiting reactant. So what we always do with this kind of exercises is like the step 0 is going to see if the equation is balanced, okay? If it's not balanced, we have to do the procedure. If it's already balanced, we can move on to the next one. So let's see. We have going to write the equation again because I like that way a little bit better. So silicon dioxide plus 4 hydrogen fluoride produce silicon tetrafluoride and 2 molecules of water. So that is like the equation for this. I'm just going to move it a little bit to the center. Okay. Okay. So first we need to see if it's balanced. Question: is this equation balanced? Yes or no?
No. No, yes. Yes.
No or yes? Okay. If you don't trust me,
Yes.
okay. If you don't trust what you see, you can always check. Okay, both sides of the equation. It's always a possibility. You can compare the silicon, the fluorine, the hydrogen, and the oxygen. So by comparison, you can tell if it's balanced or not. So let's see. 1 against 1, 4 against 4, 4 against 2 times 2 that makes 4, and 2 against 2 times 1 that makes 2. So as you already said, yes, it was balanced, but it's also a good thing that we always check if the equation is balanced, because you don't know if Martinez is crazy and she's going to give you one coefficient but not the other one. Imagine that you just trust in the coefficients I give you. So no, you always need to check if it's balanced. Okay, because you don't know how concerned I'm going to be and I can forget something. So you better check that it's going to be the step 0. Now, we focus on the question and it says, if 6 moles of hydrogen fluoride is added to 4.5 of silicon dioxide, which is the limiting reactant. So what I'm going to do now is I'm going to write the data given in the problem. So it says 6 moles of hydrogen fluoride. I'm going to write the data right here, okay? Just to have all the information visible, very visible, okay? Jennifer, you need to keep your camera turned on. Thank you. Then it says that from silicon dioxide, I have 4.5 moles. Now, take a look. I'm going to ask you a question. I'm talking about the same topic again, okay? So just think about the question that I'm going to make. Imagine that you are a chemist, okay? And you are in a lab, and I'm giving you 2 substances, substance 1 and substance 2. And I say, this substance cost $100. This one costs $50. And the product, so if I'm going to combine very expensive substances, $150, for example, I expect to get even more expensive product. So which one do you think is more expensive? Silicon tetrafluoride, water. Which is more expensive? In your opinion, just, I'm not asking you to look for eBay to see how much it costs. No, I'm not asking you that. Just common sense. Which one do you think is more expensive?
Hydrogen
Silicon
fluoride.
dioxide.
Which one, sorry?
Silicon dioxide.
No, I'm asking about the product, okay? Which one is more expensive? Silicon tetrafluoride or water?
Silicon tetrafluoride.
Yes, imagine that I give you $150 to produce water, a glass of water. That is very expensive for a glass of water, right? So in situations where the chemical formula is producing water, we always going to focus in other products, not water, because water is basically a side product. Okay, I don't care about water very much because water is a very common substance and it's very cheap. Okay, and it's very cheap. So we're going to focus only in the more expensive substance that is produced. In this case, the more expensive one is going to be silicon tetrafluoride. Now, water, I'm going to just write that it's a very common product, so you can ignore it, okay? But sometimes, and most of the time, basically, the problem will ask you what product is the one that you have to focus. So right now, the problem is not telling you anything. So common sense, what is more expensive? Well, any other thing except water. Water is very, very cheap. And now, after this analysis, okay, we, as every step that I gave you in chemistry, we're always going to start with the givens. Okay, so you have two reactants. Reactant 1 and reactant 2. Where do I get the reactants? From the chemical equation. So I have my chemical equation. I have my first reactant, silicon dioxide. I combine with my second reactant, that is hydrogen fluoride. So yes, I have two reactants. So my first reactant is silicon dioxide and my second reactant is hydrogen fluoride. Okay, hydrogen fluoride. So the idea is that you're going to work with those reactants separately. Okay, so we always start with the given and we say from silicon dioxide, the problem is giving me 4.5 moles. I'm going to start from there. 4.5 moles of silicon dioxide. And I will multiply by a conversion factor. Now, by definition, limiting reactant is the reactant, no, sorry, that's the reaction, sorry. The reactant that produces less of a product, okay? So I'm going to focus on the reactant that produces less. To know which one produces less, I have to compare both reactants. So to know, okay, that means that I will care about the product, okay? What matters is the product. So I'm going to put it here. So I want to know which one of the two substances, one or two, are producing less amount of silicon tetrafluoride. So we have to see which reactant produces less silicon tetrafluoride, okay? Or the product that you care about. So To know which one produces less, we can make two procedures. You can get from in this case I'm giving you moles, okay? So you can do a conversion from moles to moles or from moles to grams. If I give you grams, you can make from grams to moles, okay? To see which one produces less by just comparison. Now, the procedure that I suggest is that you make only from mole to mole conversion because it is easier. It doesn't mean that if you want to make from moles to grams, it's going to be a lot more difficult. No. If the question is very simple, just telling which one is the limiting reactant, go simple. Go for mole, not to mole. Now, if the problem asks you, what is the amount of product that I can get, then in that case, that a problem specifies that you want the problem wants to know the amount in grams. So yes, you have to do the conversion in grams. When it's not specified, go simpler. Go to moles, okay? If you have more moles, it means that you have more mass. So it's more like an analysis kind of thing, okay? Analytical. So if you have to do a procedure from moles to moles, means that you are going to be using molar mass or molar ratio. What are we going to be using? Molar mass or molar ratio? For a procedure, mole to mole.
Molar radius.
Molar ratio.
Guys, give me a second. Give me just a second. Sorry, guys. Oh my god. I'm embarrassing. But these people already finished the install their internet service, so they wanted me to sign a few things. So I was saying, I already forgot. You are doing a conversion moles to moles, okay? Which means that you are relating only moles against moles. And the conversion factor that relates both moles and moles is just molar ratio, okay? So as you said, molar ratio is the one that we need to go with, okay? So remember, from mole to mole is moles against moles, that means molar ratio. Now, let's see. What will be the molar ratio between my given and my unknown in the first reactant? What is going to be the molar ratio that I need to use?
4 moles of hydrofluoride and 1 mole of silicon dioxide.
Okay.
One
One mole
mole silicon.
silicon dioxide in the bottom. And in the top, what am I going to write?
4 mole of hydrochloric.
No. What is the substance that I want to know? The product.
The product.
Okay? This one is the one that I
Silicon.
care. So yes, it's going to be silicon tetrafluoride. So this will be 1 mole in the top of silicon tetrafluoride. Remember that when we have okay. So remember that when you don't see a subscript, it's invisible. So this is like having invisible one here and invisible one in the product too. Okay, that's why the conversion factor is 1 to 1. Now, when you transform this in your calculator, you get the same response, 4.5 moles. But in this case, since you are eliminating the moles of silicon dioxide with the moles of silicon dioxide, the units that you have to write are silicon tetrafluoride. So these are 4.5 moles of silicon tetrafluoride. That's the product of one reactant. So we're going to focus on the second reactant. In the second reactant is hydrogen fluoride. The problem is giving me 6 moles. Okay, so I begin always with the given 6 moles of hydrogen fluoride. Now, what is the molar ratio that I'm going to use that relates hydrogen fluoride and the unknown silicon tetrafluoride?
1 mole silicon tetrafluoride over 4 mole HF.
Exactly 4 moles of HF. With this, you know that you can cancel units and units. And how much do you get as an answer?
1.5 mole silicon of what? 1.5 mole of silicon tetrafluoride.
Tetrafluoride, that is correct. Now, you have 2 answers, and now we need to answer the question. The question says, which is the limiting reactant? And I told you in the beginning, the limiting reactant is the one that produces less. So which one is the limiting reactant?
The second one.
The second one. So because this is the lesser amount, okay, of product, I have to write the reactant that produces the less. And that reactant is hydrogen fluoride. So by answering the question, we say the reactant that produces the least product is HF, hydrogen fluoride. And with that, we already decide, we already shows, we already answered the question. Therefore, the excess reactant or reactants are going to be the rest of the reactants in the reaction. You're going to have always one limiting reactant and whatever amount of excess reactant. So the excess reactant is going to be the other reactant, okay, the one that produces more of a product. So this is going to be excess reactant. So hydrogen fluoride is going to be the limiting reactant. Okay. And with this, you answer the question. Now, I know that this is like the first time that we see this topic with a real equation. So I'm going to show you an equation that is a lot more simpler, okay? So let me, all right, well, so I'm going to put an equation right here, very, very simple. This is an example too, okay? Example two. So I'm giving you a reaction between sodium and chlorine to produce sodium chloride. And I'm going to ask you, which of the reactants is the limiting reactant? Which is the limiting reactant? Okay, so for this exercise, what we do is what we always do in the step 0. We need to check if it's balanced. Is this equation balanced?
No.
No.
No. How do you balance it?
Placing a 2 in the product and in sodium.
That is correct. Now it's balanced. Now it's balanced, okay? So we move on. Now, to know which one is the limiting reactant, I have to give you amounts, okay? So let's say that I'm giving you 5 moles of each, okay? I'm giving you 5 moles of sodium and I'm giving you also 5 moles of chlorine. And I tell you, guys, which is the limiting reactant. So you need to work with the reactant separately, okay? Separately. So I'm going to work in this part only with the reactant 1. That for me is going to be sodium. And here the reactant 2, that is chlorine, okay? So I'm giving you an amount of 5 moles of sodium. So I need to use a conversion factor. What conversion factor am I going to be using? Molar masses or molar ratios?
Molar radius.
Okay, molar ratios. Okay, what molar ratio am I going to write? Where am I going to write the sodium, up or down?
Down.
So how many moles of sodium I have in the reaction?
2.
And in the top, where I'm going to write?
The product.
2 moles of NaCl. So here you can cancel. What do you get as a product?
5.
5, okay? You're gonna get 5 moles of NaCl. Now let's do with another reactant, okay? Chlorine. For chlorine, I have 5 moles, okay? Now, what is the molar ratio that I'm going to use here? I forgot that too, okay? How many moles of chlorine I'm going to write in where?
1 mole down.
1 mole of Cl2 comes down. And in the top, how many moles of sodium chloride?
2.
So this, you cancel the moles of chlorine with moles of chlorine and gives you, as a result, 10 moles of NaCl. Okay. Now, what is the limiting reactant? Is it sodium or is it chlorine?
Sodium.
Sodium.
It is sodium because sodium produces less. 5 is less than 10. So the limiting reactant is the reactant that produces lesser product. Okay. So you can just indicate that this is the limiting reactant. Therefore, the excess reactant is going to be chlorine. Sorry, excess reactant is going to be chlorine, like that. Now, with this, you already solved the example number 2. Do you have a doubt in the procedures?
No.
Okay, look, other problems are going to be more specific. Let me show you something. Other problems are going to be more specific. So let me show you. Now, for example, this one, I'm not doing it because of the time. This problem has 3 questions, so it has 3 procedures. It's like having 3 exercises in one. So I'm not going to teach it today, but just for you to know. Let's analyze this word problem. The black oxide of iron, F3O4, occurs in nature as the mineral magnetite. This substance can also be made in the lab by the reaction between red hot iron and steam according to the following equation. Iron plus water. Okay, it says red hot iron, element iron, plus steam. Steam is water vapor, okay? So you have there water in a gaseous state. And this produces magnetite, and as a side product, it produces hydrogen. Now take a look in this one. It says when 36 grams of water is mixed with 67 grams of iron, which is the limiting reactant. So here, because the problem is giving you grams, you have to do a longer process. When the problem gives you moles, it's easy, okay? If the problem gives you grams, it's a little bit more complicated. So we are going little by little. Today in classroom, I'm not sure about the time because I need to leave house. And so I'm not sure about the time. I'm gonna need that you be attentive with the classroom, with the Google Classroom, okay? So because I'm going to send